Sudoku degenerates, welcome. This is the new Fortress Philomeno. Oh, hey, Q, welcome. I guess it's not the newest Fortress Philomeno. I did, Hey, math guy. This is a collab between Math Guy and Soder. Oh, you're right. This was the one that you made for Stu's birthday. Or was it for the train? Or both? Could be both. So it's Fortress Philomeno, so I divide the grid into orthogonally connected regions and fill each cell with a number 9 or less, showing the number of... Nah, it was train. Stu's birthday gift was much more cursed, as I imagine. Because this one had to fit within a 3-hour time slot, for one thing. Yeah, it was about the same time. So I divide the grid into orthogonally connected regions and fill each cell with a number 9 or less, showing the number of cells in the region to which it belongs. Each region must be either strictly larger than all of its orthogonal neighbors or strictly smaller than all of its orthogonal neighbors. The values on columns and rows read in both directions make a total of 24 numbers of 6 digits. Yeah, I did. But it's showing Soder as being offline. Then again, it showed you as being offline too. Clues outside the grid show the rank for the indicated row column among those 24 numbers, where the lowest is 1 and the highest is 24. One or more equal numbers are considered to be at rank n when there are n-1 numbers of strictly lower rank, meaning ties go to the lower rank. For example, say there are 3 numbers in rank 20 when there are 19 numbers of lower rank, and the next rank will be 23, so they go 19, 20, 20, 20, 23, so they skip over intervening ones. Alright. Oh, hey, Ambrose. Now, the one issue is this does not have to be... Let's see, how do I... Because, like, these don't have to be in different regions, because they could have very different... And there's no... Did I say hi to Ambrose just now? I think I did. I can't remember. Okay. So 1 here and 2 here. That has to be important, but I don't see... Ah, good to know. I'm not completely losing it yet. I guess I know it can't be symmetrical. Oh, this rank. It can't be equal to 1. It could be equal to 2. But these... Okay. Trying to figure this out. Okay, so 2, this rank. Yeah, these have to be the same digit. It's probably pretty low. I'll call that A, and I'm guessing it's a 1, but it could be like 2 or something. It's possible there's no 1s anywhere in the puzzle, or at least not on the outer edge of the grid. But wherever this breaks symmetry, this must be lower than this, which must be lower or equal to this. Oh, and this can't be... This can't be high unless it takes... Unless there's no lows anywhere on there. Right, so this is low. So this is 2, 3... I guess it could be 4 or something. Well, we'll see. Now, if these are 1s, then these are all pink. And at least some of them probably link up to each other quite a bit. Oh, did these have to be? It's a little fuzzier here. How does this 7, 8, and 16 interact with each other? I guess this must be equal to or lower than this. And equal to or lower than this. So could these just be 2s? Does something break if these are all 2s? Well, then this must be 2, because of these ranks. It's not possible for this to be 2. Because you can never have a pink 2. By Fortress Philomeno. So there is always a border here. Oh, and there's also this rank. If this is pink, this is also pink, which would make this symmetrical, and this would have to be equal or lower than this. Now, is it possible that, like, these are all... but these ranks... This also has to be A, because if it's not A, these ranks will get me to at least 4. If this is 2, and this is 2, this also has to be 2. So this would be at least 8. Whereas if this is 2, then these all have to be 2. In which case this is also A. So, but if these are 1s, this doesn't necessarily have to be 1. It does still have to be pretty low, but I'm not sure how much pretty low actually is relative to the rest of this. I guess you could have a pink 2 in like an irregularly shaped grid. Well, sorry, mind is... what am I doing here? What am I meant to... Is there some global reason why these cannot be the same? I mean, if it is, then these have to also be the same. I guess it is possible there's only like 2... There's only 2 distinct digits on the edge? It feels like that shouldn't work, but I'm not sure why it doesn't. Okay, let's say... If these are 1s, these are pink, does that... Okay, let me see if I can... Is there some way to prove, just without even thinking about this, that these have to be different? If these are the same, then there must be a lot of this digit on the edge, but the thing about Philomeno is that's kind of fine. I guess I could worry about what digit it is, but... Oh, wait. Whatever this digit is, Okay, this has to be either rank 5. This has to be rank 5. I feel like... I feel like I'm either leading up to a situation where these are all 1s, or... Wait a minute. There's no way these are all 1s. That breaks this. Oh, right. Yeah, it could be... Yeah, this could be like 9 or higher. But if that's the case... then these are all the same. Well, if this is rank 9 or higher, then these are all the same. That is probably... I guess it could be blue 3s here? No. If this is rank 5... Yes, okay. I guess... What ranks are these? They're either another of 2, a 3, another of 4, a 5, another of 6, a 7. Oh, another of 6. No, there can't be a repeat of... I guess there could if there's no... Wait, no, ties go to the lower. So the fact that there's a 6 and a 7 means there's only one 6. Yeah. The fact that there's a 7 and 8 means there's only one 7. So these are either from 3, 4, 5, 8, 9, or higher. If these are all 1s, I do have at least 9 separate ranks to account for. But what if these are 2s? This has to be 2. But this can't be, because it would be... Oh, but, okay, that broke. So this also cannot be 2. So So either these are all 1s, or these are all 2s. If these are all 2s, even if I do it like that, that's still 5 ranks. Oh, and these have to be higher. So this cannot be 2, so this also has to be higher than 2. But is there... I mean, this has to be higher than this. It doesn't have to be the same color, though. It could be... Why does this break? This joins either this, creating something that's at least 7. That would probably be an issue here. Oh, this cannot be... These can't both be pink in that case. And this has to be higher or equal to this, so... This probably links up here. Oh yeah, 1 and 2 are tied here, right. Duh. Okay, and these are from... Well, I mean, if this is also if these are also 1s, these can be... Okay, but these... That forces all this. These can't both be blue, so this does have to get out, so this is at least 4. Right, and these can't all be pink. Can they both be blue, though? Well, I know this is always blue. So this gets out here. And a tricky thing is this being 2 does work. Although it does make this at least 7. So this would have to be blue. This... Okay. I am slowly learning how this puzzle works. Okay. There has to be more blue in here, but it can still be a much higher blue than... If these are the same, goes here. If this isn't a 1, these are all from 3, 4, 5. Now, if I don't know... Oh, but wait, if it... Oh, no, wait, these could still be different if these are the same. It feels like it it has to break somehow if these are the same, but I can't quite see how. Threes? Oh, I do see sort of way that works. Oh, wait. Oh, well that... If this works... Oh, wait. Oh, no, this... Okay, either way, this is always lower than this. Now, is it possible this is only 3? Oh, no. Well, at least not there. Maybe if... Wait. Huh. Okay, this... I mean, this is 1 or 2 in this world. What's wrong with this? This is at least 7, so it can't take... You can take a max of 2 more. Oh, but... Okay, this... Oh, but I can't make this a 1 now. Right. Okay. I see what to do. I see... Well, I see sort of... I see... Okay. I've got... That's 5. If I make this a 1, I now have 7. So... Alright, I can't have 7 1s unless this is also a 1. But if I make this a 2... Oh wait, no, because the other ranks could be higher if this is also a 2. Actually, wait, does that work? If I assume this is like that... Huh, this works suspiciously well. doesn't even... I mean, there's probably some reason why this doesn't work. This has to... That's 8, that's 8. Oh, but then this is lower than this. There has to be something else to see here, but... Okay, so what am I proving? This can't be 1 unless this is also 1. Oh, but wait. There can be a max of 8 ranks higher than this. So if... That's too many ranks that are higher than this. So if this is... So if this is pink, it joins this. And it has to be lower than this. And this. Well, it has to be lower or equal to this. And this has to be lower or equal to this. And... Oh, but wait. Oh, if these join each other... Right, okay. If these join each other, we have problems here. Because I know that this isn't lower or equal to this, it's just strictly lower. So this cannot be equal to this. Okay. Can never have a pink 2, so that does get out there. So this must be greater or equal to this. Probably strictly greater. Oh yeah, it has to be greater. Oh, well, no, it could be equal because this is always higher than this. But because this is lower than this has 3 of the 8 ranks higher than this. And because it's lower than this is 2 more of the ranks higher than this. So these are all from... (17 to 24). This is lower. So these are the higher ranks than this. So what I need there is... I can only have 3 more ranks that are higher than this. So I have to be very careful about growing these. Certainly not there or there. Of course, I say I can only. I must have exactly 8 ranks higher than this. Or equal. Ah! So this is not pink because these don't join up. And this cannot be 1 unless this is also 1. So this is the same digit as this. Probably 2? If this is one of them, this is 4, 6, 7, 8, or 9. These corner marks are cluttering, so I'm gonna mark a rank yellow if I know it's higher than this. This is lower. All of these are lower. Right, this can't be 1 unless this is also 1, because of the number of ranks. So this is 2. Okay, so if it goes here... Oh, wait. Oh, then this is 2. If it goes here, this is 2. This is 2. And this has to be part of it. Now these can't join, or this is... but this could still be 2 rather than 1. So this is at least 7. If this takes this, it becomes 9, then this is yellow. But then these are all... Oh, and either way, this is going to take another 2 that is a rank... Oh no, the other 2 could be rank 5. Oh, wait, no. Rank 5 is up here. Or a tie for rank 4. Oh, I know this is 3. If this is blue... Oh, it has to be a 2 or a 3. What about this? If this is 2... Oh, wait. This has to be lower or equal to this, and it can't be lower. So this is 2. God, I should have spotted that sooner. Okay, so this is at least 3, and it must be at most 3, so it is in fact 3. Oh, if this is 3, these are both blue, making that a 2. That breaks. Okay, so this is the next 3. Wait, what? Oh god, how far back do I have to... Well, really? These being 2 broke? What is this? But how? Are either of these 3? Okay. So I guess I was correct about it going up here? No, I guess this is always... Why did I think this was 2? Times like these, I'm grateful no one watches. Okay, but if this is 1, that's too many rank 1s. Yeah, that's 7 ranks that start with 1. That doesn't work. So this is the same digit as this. Why did I think this had to be 2? the other one can be higher than... This can't be 2 unless this is also 2. But any other ranks this sees can be higher. So what... This also has to be 6, 7, 8, or 9, because it has to be equal or higher than this. So this is either the same as this or it's higher. If this goes down... These all being 3. Oh yeah, this does have to be equal or higher than this. But this has to be equal or lower than this. So this being 3 makes this 3. Going here breaks this. Oh, also, where would I get the rest of the 3s in between here and here? Yeah, there just aren't... These can't be the same because I've run out of room to place the remaining ones. Okay, so this is lower than this. Right, okay. And it doesn't join this either. Forces this, but now this has to be... Now this is 7 over 9. This is another 1. This is also 7, 8, or 9. But these can't join up. Oh, but this has to... Right, this has to join this. Whew! That was brutal. I probably could have... Oh, this is high. Right, this is the only thing higher. Okay. Whew. This is rank 9, rank 10. This is rank 11, 11. This is rank 12. Oh no, this is rank 11. Oh no, this is rank 11, this is rank 12. This is 13, 14, 15, 16, okay. Whew! Okay, you're welcome for solving. That was quite... probably should have picked something a little easier to warm up. Oh, maybe I should have gone with this to warm up. Yeah, that was mind-bending, but really neat. This is only rated 3 stars, despite the much more intimidating sounding rule set. The cheese is good. Good to know. Oh, you got the LMD code 6. That's nice. It does help solving the G's if you read the rules fully. I failed at the initially. Well, thankfully I do have a decent track record at reading rules fully. Barring a couple exceptions. Divide the grid into 9 orthogonally connected regions and place the digits 1 to 9 once each in every row, column, and region. Okay, my eyes are playing tricks on me. Something about the color of... There's some kind of optical illusion effect that makes me think any line I'm not looking directly at is hollow. Well, anyway. Counting circle cave clue cheeses. A digit on a cheese round counts the number of cells seen in its row and column, including itself, where region borders block sight. Also, a digit on a cheese round indicates how many times that digit appears on cheese rounds. Skyscraper sweeper slices. That is a horrifying combination of words. The symbols cheese, pizza, and cooking pot represent 3 different digits from 1 to 9. Outside clues indicate the number of cells seen in the direction of the clue from the grid edge until the first internal region border. Also outside clues are skyscraper clues. Oh, okay, so it's not... Okay, so it counts the number of cells in the first region, and... But they don't all have to be visible from a skyscraper point of view. Okay. Cells joined by a tomato have digits that sum to 10 and belong in the same region. And cells joined by a black olive dot. Oh, you animated a little attention to detail. Have digits in a 1 to 2 ratio and belong to different regions. Okay. But, okay. So, how many counting cave cheese clues? Are these the moon emoji? Oh, they'll serve as cheese wheels in a pinch. After all, they know what they say the moon is made of. Okay, that's 10, 13, 16, 20, 22, 25. Okay, 27. There's 27... the moon is made of, I guess, yellow cheese instead of green cheese. Who knew? Okay, so there's 27... Alright, bye, math guy. There's 27 in 5 different cells. In at least 5 distinct digits. And... okay, if there's a 1 in there, then there's 6 digits. Because I can only... these are different rows, so they don't... so I can't have 1 in both of those. There's also 5 in this column. So could I have a 2 here and another 2 here? With the remaining 4 cells summing to 25? Without using a 1? That's way too easy. Because... okay, if it's 5 distinct digits, then it's very close to 25. So that is... okay. Oh. This is a max of 2. Oh, and... right, neither of these... I can't have 2 1 skyscraper clues. Because if a skyscraper clue is 1, the first digit is 9. So these cannot be... right, these have to be... right, and the second digit seen is 9. Now... oh, and I can't put 9 here. Oh, and I also can't put 9 on a moon, on a cheese, because in this row, okay, so there's a 9 here. This is at least 3. Wait. Why did I say there couldn't be... oh yeah, I couldn't... right, there couldn't... if there's a 1, then there can't be 5 digits. Because that breaks up here. Okay, what about... there could be a 1 if these are from 5 digits. Okay, oh, I also know that the first region border is here in this row. I also know that 9 in this row goes up here. One cheese don't know if these are all part of one region. And I gotta remember, each counting clue is also a cave clue. Oh! Well, you can never have a 1 on here. Okay. So is it 2, 3, 4, 5, 6, 7? Eight pizzas. I mean, that's not that bad if they're small. Or if you're cooking for multiple, though. Also, 7 of them went in the freezer. Ah, okay. Pizza skyscraper, yes. Yeah, that is a pizza skyscraper. So what? I know these are 2, and I know these are distinct digits, so these are not... Oh, wait. This can be at most 5. Oh, can be at most 4. Oh, and these also cannot be 1. Oh, and this is 1 or 3. So one of the, this has to be 9. Because I can't put 9 on here. So the 9 has to go here, can't go here, and it can't go here because this is at least 3. So if I put it 1 or here, the max this could be is 1 or 2. No, this is 9. So this is 3. So this is 1. So the cooking pot is 1. So these are 9s, and also there's a, oops, there's a border there. Oh, and there's a border there, and a border there, and no borders here. Ah, but because these are in the same region, these are in the same region, I can draw that. Ah. So these are all in the same region, so these must also be... common pizza. Oh, yeah. Wait. Huh? How do I... Oh, wait. Okay. This cannot take this. this has to take this because this can only join that. But if it takes this, it now gets cut off. So it has to go out here. So in fact, this is a separate region, which has to get out through here. So this is at least 5, and it's not exactly 5. So this is 6, 7, or 8. So this is 2, 3, or 4. I also got to remember this is a 3 skyscraper clue. In fact, that's going to be very pressuring for this. Okay. Okay, this is 7, so it takes 2 more. Takes at least one of these. Oh, there's also... This is 5, 6, or 7. And the cheeses are also skyscraper clues. Gotta remember that. So this has gotta be higher than... Oh, I can't put 8 before the 9. So no 8 on here. Oh, this... How did these... like... I think if I draw a border here... Yeah, this region breaks. It can't take 9 cells. So this has to get here. I just don't know about this. Oh, but then, since these are all part of the same region, yeah, that takes this. Probably takes whichever of these are not taken by this as well. Oh, unless it's like this. Oh, but this has to take at least one more, no matter how many of these it takes. Because it can't take all of these without cutting off this. Oh, but the fact that this is at least 6 means it does take that. Oh, but wait. Now it's at 8 cells, so it can't take both of these, and this has to take this, so it cannot take that. This is, in fact, a 6. So this is 4. Now, either these are all less than 6, or these are strictly ascending with this being greater than 6. Huh. Oh wait, no. It's possible that there's an 8 in here and like a 7 or something here. No 9 here. And here. Okay. Oh, wait. If this is enclosed, this becomes a 4, which it can't. So it becomes a 5, and we do that. So I know there's a 5 and 6 on the... I'm guessing the counting circles are 2, 3, 4, 5, 6, and 7. This becomes a new region that is not part of... Oh, hey, Black Doom! This is also lower than this. Now, if there is an 8, can there be an 8, like, here? If so, then there must be an 8 in every row where cheeses exist. Things I say on here. Oh, wait, this being an 8 breaks here. Breaks one of these 2 rows. So this is not 8. Doesn't tell me that much about what it is. Now, having a 2 on a cheese is very difficult indeed. Well, no, there are a few places where... This would be... I guess 9 in this region can only go in a few places. Oh, there's also... where's... And of course, with Cave Sudoku, you also have to... Like, I can't do that because then these would both be 4s. Actually, does 8 actually work as a... means one of these is 8. One of these is 8. Means this is 8. It works pretty well on this. Maybe I can, Oh, this is only 3 or 4. So no, 8 does not work on any of these moons. 7 would be very weird, though not, I think, technically doable. Okay, so this is 6 or 7. So this is higher than this. So this cannot be 9. 9 in this column only goes here. Oh, this has to be higher than 5, but lower than 9. So this is 6, 7, or 8. This cannot be 8. This is 3. Oh, I guess it could, like, get up through here, leave these to get, yeah, or even through here. I think if this is 3, it needs to also take this, for what that's worth. Not quite sure. Oh, well, this is only from 1, 2, 4, 8, because it's not a 3, 6 pair. I know this is not 8, because there's no 8s on the... Oh, and there's no 1s on cheese. Oh. These cannot be pink because it makes both of these 6s. So there has to be a border here. Is 9. I've also got a 8 here. 8 in this column can only go here or here. If this is 8, I think this has to be 7. But if this is 8, this can be anything. Oh, this cannot be 6. No. This is either 5 or 7. So this is either 2 or 3. If this is 7, I need 6 more 7s. And at most one of these can be. So I would need... a 7 in here. 7 in here. 7 in here. 7 in here, and 7 in here. Is that possible? But if I can't have 8... Oh, well, if I can't have 8 or 9, I do in fact need all... Oh wait, no, this isn't 2. This is either 3 or 6. Ah, but this cannot be 7. So I do need and if I can't have 8 or 9, I do in fact need 7. I need it to be exactly 2 through 7 on the thing. So this is 7. There's a 7 in here. There's a 7 in here. And we do... So where's the... What does the 7 in here actually say? Could do that, and this could see that, and then it goes, yeah, that's a couple different ways that works. These pencil marks are getting a little, the corner marks are getting a little confusing. I'm gonna try and keep them closer together. Ah, if this is 8, this has to be 7, which it can't. So this has to be 8 now. So this is good. I will gray that out because it is satisfied. Oh, these are... This cannot be 7, so the 7 up here goes up here. So these are my candidates for 7. Oh, wait, where does 7 go in this column? It has to go there. Okay, and... Oh, it sees all of these. Oh, that's... I'll reuse pink, because... Oh, this has to take... This could be a different region. Well, we'll see that in a second. Okay, it sees 3, so it needs to see 4 more in its row. Either way, it sees all of these. Oh wait, this cannot be 7 now. Because it would have to be in a separate region, I can only see 6. So one of these must be a 7. if it's here, that is very forcing indeed. Also, hi, Screaming Ice Cube. 5 in column 8. Right. It's in one of these. Oh, can't be here. So this is 5. Okay. Sees 2 here, must see 2 in its row. So this does see this. Does it take this as well? We shall see. This is already at 7 cells, so... And these are from 2, 3, 4, 6. I don't think... Yeah, this is at least... Oh, this is exactly 6. Right, because it sees 5 in here and 1 up here. So I know that this border exists, which means this border exists. Now this sees at least 3. Oh, this is 6. So this is 8. Oh no, this could still be 6, so this could still be 3. There's probably some reason... Okay, this doesn't work as 6, so this can no longer be 3. So there's always a 2 here. There's always a 4 up here. This is satisfied. There's 6 on here. No 8 or 1 on a moon. Oh, 8 can't go here. It also can't go here. Oh, unless this is 9, which it still can be. Okay, have I made any more progress on the 7s yet? Doesn't seem to have yet. If this is 7, can't join this. Has to take those. I guess 7 in this region has to go here. Oh, that's a little X-wing on 7s. I have a bent X-wing on 7s. Rule 7 out of here and here, so this is 7. Okay. Oh, also rule 7 out of here, so this is 7. Good to know. So, this sees a max of 6 in its column, so it does take that. This sees a max of 5 in its column, so it does take that. little easier to see. Oh, this is always satisfied. Oh. This can't be 1. This has to be lower than this. Because it has to see the 9 somewhere in here. Ooh, yeah. It could get it here. Oh, wait. Yeah, oh, well. Okay, so there's 2 spots for 7 in this row. In this row, it can only go there. This column only goes here. And this column only goes here. What about this column? Oh, it could get it here. I think orange has to get its 7 here, right? Oh. And either way, this can never be 7, so this has to be. Because if this is 7, that's 7, so this isn't 7. And if this is 7, obviously this isn't 7. Oh, and also this is never 7. Interesting. It's either 3, 6, or a 2, 4 pair. Oh, yeah. Because it's not 7 or 9. This is not 4 or 6. And this is not 2, because it would have to be lower than that. So that is 8, that is 2. Okay, so that is done. That's not 2, because it's in the same region as that. So that is not 4. Oh, wait. This takes this, so it has to be part of green. Okay, that was... Should have spotted that sooner. I don't think it gets me anything immediately, though. This sees at most 2 here, so it has to see at least 5 here. So, this has to be orange, unless it... Oh yeah, this is from 1 or 2. Oh, this sees at most 6 here, so it does need to see at least 1 more here. And now... now this cannot be a new region. This has to be orange. If this is 7... Oh, wait. I miscounted. Yeah, that could be how red goes. Oh yeah, but this does have to be red. So, in fact, this is not a, this is not red. And these are all from orange or red. Now, I can't have these be the same digit. Right, so this has to be orange. Because this can't take both of those, otherwise it's closed, and these are the same digit. Oh yeah. This sees everything but 1 and 3. So I need at least one of these to see one more. But they can't both see one more. So this is a 5-6 pair, right? Oh, this is 5, this is 6. So this is 4, this is 2. If this is 1, this has to be 9. In fact, I'm pretty sure this is all... Oh, this isn't 6, so this isn't 3. Oh, this is 4. So this is 2 or 8. Oh, wait, this... I'll reuse blue. I know this takes this, but I know this can't be the same region as this. So it sees a max of 2, so it needs to see at least 5 in its row. So it does take all of those. And it sees at most 6 in its row, so it does need at least one more in its column. I still don't... Oh, this is a 2. I'm guessing it's this? Oh, but... Oh, this cannot be red. Oh, now if this takes this, it gets cut off. Oh, unless it also... Oh yeah, I could still do that. Thus making this a 3. Oh, I gotta be careful. Oh, but wait. Isn't this always a 4? Yeah, this is always a 4. Because I know it sees... Because this 5. It sees... Yeah, this is 4. Three, 5, or 6. Oh. Eight in row 7. Well, it can't be here, because that breaks this. So it's one of these. Yeah, 8 has to go here in this. So the 9 has to go before it. If it's here, this is 3, this is 1 or 2, but that's still fine, I think. Oh, this... Can 8 be... Oh, no, 8 can't be here because of this. So this is 8, this is 9. Okay, so this is satisfied. There's an 8 here, 7 here. This must be at least 4. No, it can only be 4 or 5. This is not 2. Okay. So this is a 1, 2, 3, 4 quad. Oh, wait, what's this then? This is 5. Ah, this is 1, 2, this is 4, this is 5. Oh, and there's a 2 here, so this is not 2. Oh, so this is the 3. Okay, now this is satisfied, no matter how I resolve anything else. Ah, this can only be from 1 or 2. And there has to be a 9 very soon after this. The 9 in this column, either this is 1 or 9, basically. Oh, I don't think this can be 4. Oh, well, the reason it can't... It has to be the same as this. Oh, yes. This is 1, 2, so this is 3. That leaves 7 and 9 here. Oh, there's no way for this to be 7. Because it can't join this, that's too big. And if it takes this, it still only sees 6. So this is in fact 7. And sees a max... Okay, so it is part of orange. So it sees a max of 4. Here, so it sees... Oh, this is 9. This is 7. So this is 7, and it has to be the orange 7, as I'd suspected. Oh yeah, this is a naked 6. What am I doing on 6s? I still need 2 more of them on moons. That's going to be interesting. Sorry, on cheeses. But this makes... Oh yeah. Oh, it could get it here. Oh no, wait, it can't. Yeah. Okay, so now this has to get up. Oh, this could join this, but it cannot join this. So in fact, this is red, and this is 3. Ooh. 9 in this region. Okay. And this is 1 or 4. So one of these is 2. Oh yeah, I should resolve this. That's 8. Ah, that forces that. Oh, so does this. Okay, so this is 9. So this is satisfied. Oh, wait. No, it can't join this because that breaks this. So this has to be something new. Oh, and it pretty much has to take this, doesn't it? Oh, wait, this. I strongly suspect this is... Oh, wait, it has to do that. Because it can't join this. Okay, so that is forced. Makes that a 4. Now this has to do that, so it takes this, gets cut off. Oops. And now this, see, takes that. But this takes this now. And that is the last thing. So this is part of that. Only question is now, does it also take that? I guess we will see soon. Oh, this is 5 or 6. Can't be 5, so it must be 6. Ah, so this gets cut off here, so this has to get out through here. Okay, and now this is all forced. Okay, regions are done. Oh. This now has to be 4. This is... Oh, this is the remaining 6. This is 3, and this is 5. Oh, and this is 5. This is 3. Okay, so all the clues are done. So from here, it is just skyscraper and Sudoku. Ah, this is a naked 3. Okay, so now this is satisfied, so it's just this that I have to watch out for. Oh, 9 in this column only goes here. So now all of the outside clues are done. So I can just ignore those. Yeah. Okay. This is 2-8 resolved. This is 1-2-8. This is 1-2. Oh. This being 2 makes that 1, and that's going to resolve basically everything. Ah, that's 1. That is 3. Ah. Ah, 1 in gray. And now 1 in blue. Oh, also that's just, okay. 2, 8, 9. That's not 2 or 9, that is 8. That's 2, that's 9. Leaving 5 to finish the region. 3 and 8 in the row, resolved. Now it's just 5 and 6. Oh. Chihuahua cheese, or queso chihuahua, or queso manonita, is a semi-soft cheese that is mild and creamy in taste, making it a versatile option in the world of cheeses. The cheese is also known as queso menonita, with the name Chihuahua stemming from its place of origin, the Mexican state of Chihuahua. There, Mennonite communities have been producing this cheese for generations. The cheese is traditionally made from cow's milk and has a rich history rooted in the cultural heritage of the region. The process of making Chihuahua cheese involves careful attention to detail, from the selection of high-quality milk to the precise timing of the curdling and aging processes. One of the critical factors that contribute to the unique taste of Chihuahua cheese is the terroir of the Chihuahua region. What is terroir? Oh, a French term used to describe the environmental factors that affect a crop's phenotype, including unique environment, context, farming practices, and a crop's specific growth habitat. Okay. The lush pastures, Gouda game. Yes, Gouda game. The lush pastures where the cows graze impart a distinct flavor to the milk, which is then carried through to the final product. This terroir-driven approach to cheese production results in a cheese that genuinely reflects the land from which it comes. Additionally, the craftsmanship and expertise of the cheesemakers play a crucial role in ensuring that each batch of Chihuahua cheese meets the high standards set by tradition. In addition to its culinary uses, Chihuahua cheese holds a special place in the hearts of the people of Chihuahua. It is often enjoyed during festive occasions and family gatherings, where its creamy texture and rich flavor bring people together in celebration. Whether grated over some piping hot enchiladas or simply enjoyed on its own with a slice of fresh bread, Chihuahua cheese offers a taste of tradition and heritage that continues to captivate cheese lovers around the world. Okay. Info dumping about cheese. I can... Okay. Yeah. That was neat. All right. Alright, can I try one more of these Shikaku Sudoku hybrids? Well, let's find out in a sec. Oops. I do need to refill my water first, but, Black Doom as a cheese time redeemer. He reads an article from cheese.com. Oh. Oh, right, yeah. God, it's been a while since I've seen a Black Doom stream. I forgot about that. Alright. I gotta refill my water, but, I'll be right back. Hey, Soder. Yeah, it went well once I actually got the hang of it. That did take me a while, but it did take me a while to figure out how to approach it, but once I did, it went reasonably well. Okay, so this is Ship's Wheel by Codec. Normal diagonal Sudoku rules apply, so every row, column, each 3x3 box, and each of these marked diagonals must contain the digits 1 to 9 once each. And I also divide the grid into rectangular regions of orthogonally connected cells. Each rectangle contains exactly one circle. A number in a circle represents how many cells are in the rectangle the circle belongs to. Rectangles cannot overlap, and every cell in the grid is part of a rectangle. Digits may repeat in a rectangle if allowed by other rules. Okay, well, the obvious place to look is, like, what rectangle is this part of? It has to take this. Similarly, okay, so each of these must be at least 4. And because they're on diagonal, they all see each other, so they must be 4 different digits. These could be 9. These could also be 8. Now, okay, this. A 5 can only be a 1x5, and it can't be vertical. Oh, there's also, you know, the gimmies. Okay, so this has to be horizontal. So it must take... at least those. Okay. So this is 1. This either takes this or this. This is 1, 2, 3, or 4. Same with this. This is 2, 3, or 4. Oh, it can't be 1, so it must be at least... Oh, it's only 2 or 3. Yes, exactly. There's... Yeah, that is here. Here. Is there... This looks like something I'm expected to use the Fistamafel ring for. Especially because... Oh. This digit. The only rectangle it can be part of is this. So this is 6 or 9. Nice. And I guess, yeah, 7 does not work. Or 5 for that matter. Yeah, prime prime numbers do not work here. Oh, right, so this is a 4, 6, 8, 9 quadruple. So there is an 8 here. Oh, and now that this is closed, this digit can only take this. This cell can only join this rectangle. So that 5 is done. Oh wait, if this is 3... Oh no, one of these could join down here. I was about to say if this is 3, these both have to be 2s, but no, that is not correct. Okay, what about this? Well, this only takes this. This is only 2, 4, 6, or 8. And it's not 8, so this is 2, 4, or 6. That might cause some... The fact that my break-in was seeing these needed to be this, that just feels like... Feels like a puzzle I should use the Fistamafel ring in somehow. If this takes this, this is 6. And this joins this. This also has to join this. Oh, so this becomes 8. I guess, okay, the fact that none of these can be 8 means I can only put 1 8 in here. Row 1, column 4. Oh yeah, if this goes up, this is broken, so this does in fact do that. Now these have to join this, which does in fact make this 8. So 4, 9 pair here, but now this can only join this, which makes this 9. This is 4, so, but this can join either of these, okay. But this, this is 3 or 4. Okay, so it does... It does force this to be a single cell. This is 2 or 3. Oh. One of these has to be a 6. Oh, or this could be a 4. Wait, that would... Oh, there's also the fact that this goes out here. So this is a 2-3 pair. These are a 2-3 pair. This is only from 2, 3, 5, 7. Interesting. So, okay, this 8, it either takes those or those. Ah, but if this is 4, oh, this could still be 4. With a 2 here, 3 here, yeah, that does work. But if this is 4, this has to join that, which makes this 4. Now this is 2. So I think one of these is always 2. So this is 3, this is 2. Oh, where does 8 go here? It must go in one of these. I think it can't go here by Fistamafel, because I only have 1 8 on the Fistamafel ring. Okay, I'm proud enough of this deduction that I will explain it, that I will explain the Fisto ring. Okay. These 2 columns and these 2 boxes are a complete set of are 4 complete sets of the digits 1 to 9, as are these 4 rows. Now you will see that they overlap here. Those 2 sets of 4 sets, those 2 groups of 4 sets, they overlap here. And if you remove these digits from both, you are left with a elegant proof that in any valid Sudoku grid, the 16 digits in those 4 corner boxes have to be the same 16 digits as in this ring. This is called the Fistamafel ring. And because of this 8 here, and the fact that none of these can be 8, because none of these can be part of a rectangle that takes 8 cells, I only have 1 8 in the Fistamafel ring, and its equivalent out here is here, so this cannot be 8. This is 8. That didn't actually get me much, but it was really cool, so I'm still proud of it. Oh, it does mean there's an 8 out here. Okay. what is more, none of these can be 5 or 7. And I can only put at most 1, 5, or 7 out here. So I guess I don't even need to prove the, Well, okay. J. Dyer discovered that in any diagonal Sudoku, where the diagonals, where each of these long diagonals has the same digits, if there's any digit that does not appear in the Fistemafel ring, it must go here. Now the solution, the proof of that is actually fairly elegant. If any digit does not go in any of those cells, where does it go on this diagonal? It must go in box 5, and on this diagonal it must also go in box 5. So, how do I put 2 digits? How do I put a digit on both of these diagonals in the same box? Well, they must be in the same cell where they meet. This is a variant of the potato head theorem. So, so I know there's a 6 out here. And where does a 9 go? None of these can be a 9. Where does a 9 go in here? It can't go in there because these see 9. I know none of these are 9, and none of these, this cannot be a 9. It can't be part of a rectangle that takes 9 cells. Same here, same here, same here. This is 9. So there's a 9 in here. So I should also think about this reaches here or here. Or, wait, can this reach this? This be a 4, this be a 3. Ah, then one of these has to be a 4. Oh, no, wait, that could be a 2, and that be a 3. Oh, that does work. If this reaches... wait. Oh, but if this reaches this, then this does have to reach that, making that a 6. And if this reaches this, then that has to reach that. So, yeah, either... Oh, but these... This cannot reach that, and this reach that. Because these cannot be shared between 2 boxes. Oh, but this could reach this, and this could reach this. And similarly, this could reach this, and this could reach this. Oh, yeah, that works with this being a 1, too. If this reaches this, it's 6. If this reaches this, this is 2. If this reaches this, that's 4, that's 3, that's 4, that's 2. Okay, so this is always 2 or 6. If this reaches this, it's 6. If this reaches this, then... Oh, wait. If this reaches this, so that's 2, that's 3. Either way, this is 3. Hey, Tomberry Java, welcome. Oh, well, good to see you too. It's been a while. So this is... Okay, so there's a 2 in here. Understandable. So I know this always takes this, I just don't know whether it also takes these. So if this takes this... Oh. Right, column 5... Oh yeah, this has to be even. So this is... Okay, so this is 6. Now this... Oh, there's still a couple ways this could go. But it does... Because... Oh wait, no, this... Yeah, none of these can be a 5. Oh, wait. Maybe I haven't proven that there's... Because this could still be a 7. Yeah, I guess I can't use J. Dyer's theorem after all. Alright. Yeah, but none of these can be a 5. Oh, it proves that in any X Sudoku, any diagonal Sudoku, if there's any digit that does not appear in the Fistamafel ring, that digit must go in row 5, column 5. It is quite the thing to... It is quite the mouthful, but I don't think it's actually useful anyway, so... Yes, that is oddly specific, but there are a few puzzles where it does come in handy. Usually ones specifically... I don't think this can only go left. Then this... Oh, couldn't these both... Couldn't this be 4 and these be a 3-4 pair? And this be another 6. Oh, the left side breaks. Okay. Yeah. Yeah, that breaks these. Breaks at least one of these because of this. Yeah, I mean, this is rated 4 stars for a reason. So, I know that this takes at least one of these. So this either joins this or this. So, if it joins this, this is a 4. This... Oh. Oh, this could still be 1. In fact, I think this is either 1 or 4 now. It's 4 if it takes that. But if this is 1, what does this take? Oh, it could reach that. Okay, so if this joins this... Oh, if this only goes right, does that... no, this could still be a 2, this could be a 1, and this could be a 4. Okay, so that still works. Okay, I mean, there are... Let me see what these can be. Oh, if this does take this, what do we get over here? If this takes this... Oh, wait. If the 8 goes right... Oh no, this could be like a 4 going this way. Could be a 2 and another 4 here. There... Yes. That is... Yeah, I think... Okay, but if this takes this now... Oh! This has to go up, and now this has to join that, making that 4, but now this is broken. So this does have to take that. Well, I just randomly stumbled upon the solution, so... I would hesitate to call myself an expert at this, but okay. So, if this goes up, then these are both 4. If this goes this way... I think these are always 4 and this is 2? Okay. Ah. Oh. Ah, yeah, they can. But if this is a 4, if I can prove that this is always a 4, I will get there. Okay. If this goes here, if that takes that, it breaks because it can't be a 2. So that does not break that. So that only takes that. So this is either a 1, which breaks this, or it is a 4. Yeah, so if this is 8, so if this 8 goes here, this is 4. If this goes up here, that's 2, and now this can't be a 6. So this has to take that, so the only option is for this to be a 4. That's the only thing that doesn't break this. So yes, this is always 4. I was kind of vibe solving that. So this is 1. So this, oh, this cell, it only takes this. So this is a 2-6 pair. Now this is 4. This either goes here or here. Oh, and this is also 2 or 4, so I have an X-wing on 2s, and that coupled with that places a 2 up here. Oh, Blackthorn on to Bannon. Oh. There's one up here. Four in column 7. There. Okay, and now 4 on this diagonal. There. So this is a 4-9 pair. Wait. Oh no. One of these is a 4. Gotta... Can I do 6 in this column goes here? Oh. 6 in this box can only go here. That creates a very bent X-wing. That gets me a 6 here. The trouble is, there's 2 different ways this could go. It either takes those or that. And I think either of those... Yeah, but I think... Actually, no, it doesn't, because if this is 8 and this is 4, yeah. If this is 8, it does fix the 2-4 pair, but if this is 8... I mean, I'm pretty sure I'm also just... I also feel that way quite often. But, point is... Oh. Let's see. Eight in box 5. Ooh. It's in here. And now in box 4 goes here. Cool. Yeah. Oh, maybe it does... No, well, in this box, 9 has to go here. And this box has to go here. So what... There's an 8 up here. There's a 1 in here. And then I guess these are only from 3, 5, 7. Because they say 1, 2, 4, 6, 8, 9. Oh, this is only from 6, 7. Nice. Oh. Could be here. Oh. It has to be... Oh, maybe not, because... If this is 6, then this is 6. Oh, yeah. Oh! Right, that's a 5, 6, 7 triple, leaving this as a 1, 3 pair? Yeah, this is 1, 3. Is that resolved by anything? No, but I guess it does rule 1 and 3 out of here. Well, I mean, Sudoku also does that. Okay, ruling 3 out of here. Okay, so there's a 6 here. So if this is... then there's a 6 here. 6, 8 pair in box 5. Why can't this be oh, yeah. Right. Okay, so this does not go here. Okay. Cool. Ah, 5, 7 pair makes this a 6. Oh, so that's 4. Yep. Shikaku is done. Nice. Okay. What's left on here? Okay, this being a 5, 7 pair. Okay. I guess this digit in this box, could go any of those. Okay. What's left here, though? 1, 7, and 9. This is 5, 7, 9. Oh. Yes, 2 in box 3. Let me go digit by digit. 2 here. 2 down here. And I have 3, 2, oh. Deadly pattern, alright. Well, we're still getting close. Oh, what's left in this column? 1, 7, 9. Oh, 2 on this diagonal? Oh, yeah. There. This is also 5 or 7. So 1 in this box must go here. So 1 in this box must go up here. Okay, that's all the 2's done. If this is 1, then 1 only has 2 spots on this diagonal. Yeah, I think positive is like... I only remember this one being positive from that one joke puzzle where it was shrouded in fog, and as you uncovered it, there were positive statements along it. That was... Let's see, okay. 3, 5, and 7. Let's see, okay, so there's a... Oh, 6! 6 here, makes a 6 there. Okay, so... we have a deadly pattern on 4s. What about 3s? Only 2 spots on this diagonal for a 3. I suppose that means this cannot be a 3. Does it mean anything else? And this cannot be a 3. I have not placed any 5s in the entire grid yet. Okay, what about... I don't think I've placed any 7s either. It's not that much more... Oh, this is a 4-9 pair. This is 1 or 7. This is 3, 5, or 7. So these are from 3, 5, 7. So that's a 3, 5, 7. Okay, so this is a 6, 9 pair. Nice. Yeah, nice. There's also 3, 5, or 7. So I should mark that these are the same digit. So in this, it goes here in one of these. Now this digit in this box, it can now only go here or here. So in this box, it goes here. Oh, wait. This cannot be the same as this, because then it could never go in this box. So this, in fact, must be this digit. So it goes here. It is 7. Oops. Oh. Cool. Better. That's 3. Okay, so this is still a 1. Oh! This is still 1 7 pair resolved by that. That's 5. This is 5. Is that all the 5s? I have broken it. Let's see. Okay, let's hope I was correct up to here. And of course there's no solution check, so I can't... That's 5. So that has to be 5. Hopefully that is... That's 3. So that's 3. This is 3H. Four. Hopefully this is still valid. I haven't broken it yet. That's 5. This is 8 or 9. 7, 8, 9. 7, 9. Okay. What's here? 1 and 7. Oh. Whew. Whew. I was worried I'd broken yet another of these, but no, this is... That was correct, I just made a typo somewhere. Yeah. Well, thanks for your help. Oh. Oh, neat. Cool. Sure, I'll, Well, I don't mind a slightly belated present. Alright, well, thank you for the belated gift. So, it's Coral Corridor. Normal Sudoku rules apply, so every row, column, and 3x3 box got to put 1 to 9 once each. The pink lines are Renbans, so they contain an unordered set of consecutive digits without repeats. And the cyan lines are region sum. So, the sum of these has to be the same as the sum of these. Okay, I see the break in. Ooh, very symmetrical too. With just the crop keys. Ooh. Oh, wow, even they're symmetrical. Oh, wow, I can see why this took a while to set. Okay. Wow, okay. Oh yeah, these are all the same. And because these and these have the same sum, this is a minimum of 15, this is a maximum of 17. Same up here. This can't be 7 or 9. Now, these two digits in this box, they can't repeat on a Renban, so they can only go here. These are also the same. Goes down here somewhere. So this is 7 cells. A 7-cell Renban. It must have the digits 3 through 7 on it. And okay, where does this digit go in this box? It must go on here somewhere. There's also the fact, okay, these two go down here. And I know these are different because they share a box here. But what about... Okay, so yellow goes here in this box. So this is... Oh, this is 3 or 4. What that's worth. And these are a max of 7. Same here. And I know there is a 1, 2, 3, and 4 on here. Oh, no. I know there's a 1, 2, and a 3. Similarly, I know there's a 1, 2, and 3 here. This digit cannot go on this Renbon. Oh yeah, if this is... Oh. Yeah, this can't be 6. Or 8. Oh yeah, or 8. So these are either exactly 15 or exactly 17. And then... Oh yeah, these two digits cannot go on this Renbon. Right, so these obviously can't be 8, 9, not if they add to a single digit. So they must, or 1, 9. So they must be 1, 2. So these are 3. Okay. This can't be 3. It also can't be 4 because neither of these can be 3. So this is 3 through 9. Oh, this can't be 6 because this can't be 3. Okay, and there's a 3 in here. Oh, nice to know there's even more coming. Well, something to look forward to. Oh, right. I can't put 10 on here. Right. So I do wind up with the same thing here, even though... Oh, that's really cool. Oh, and this digit on here, it's here. So it must go in one of these in this box. Now it does not go on here. Be interesting if... Oh, let me give this its own color. I'll make this orange. Now they could both be here, or they could... These are at least 4. And... Oh. I have a bent X-wing on 1 and 2s. So this is a 1-2 pair. Oh, I also know 3 goes on a 7-cell Renbon, so it goes here, and it also goes on here. So where... So there is... Okay, this is... 4, 5, 6. If this is 3, this is 4. Then there's... Oh, this goes down here. This digit does not go on this Renbon. So this is not 6 or 7. It's 8 or 9. What is more, I know that this Renbon now has a 2 on it. But could still go in any of those. Oh, it can't go here, because this could not be 1 in that case, or 3. But any of the rest of these still work. Where... this digit must go up here in this box. Down here. Okay. If either of these was here, that would mean this is 8, and this is 9. Oh, this can't be 8, 9, or that breaks this. So, these two go here. And this is... this is 15. This is exactly 15. No 5 on here. So this is the other of 6, 7, 8, 9. Wait. Oh. Where does this digit go in this box? It doesn't go here, here, or here, so it must go on here. So this must be at least 17. And this is only 6 or 7. So there's a 6 up here. Yeah, so this is 7, 9, or 8, 9. Either way, there's a 9 in here, so there's no 9 here. You can see why... Oh. This... Alright, it goes in one of these. Also goes... Oh, did I say at least 17? Sorry, I meant at least 16. I know this one is 15, and this one is at least 16. I also have not looked at... Okay, there's also, could be 1, 2, 3, 5, 6, or 4, 7, or 1, 2, 3, 4, 6. So it could be... So there is a 4 or a 5 on here, for what that's worth. Oh, but I can't put 2 digits from 6, 7 on here. So this digit, I'll make this pink. It goes on here in this box. Now, if it's 6, this could still be 3 if the others are 3, 4, 5, 6. Oh, but wait. 6, 5. Yeah, 5, 6, 4, 7, 8, 9. Yeah, that works. Maybe a... No, that works. Okay. What about... Ooh. If there's an 8 on here... These are 7, 9, 7. Then this has to be 7. That would make this a 7. There's something on here too. Okay. This can never be... yellow. this digit must go up here, and it must go here or here in this box. If this, oh, only 3 spots for 3 in this column and in this row. So I got, oh, oh dear. Sometimes reloading helps, but not sure what. Oh. Then there's. This can't be 1, 2. Okay, so these are from 4, 5, 6, 7, 8. Okay, there is. Oh, this can't be from 6, 7, 8, 9. So this is also from 1, 2, 3. Okay, so no 3 here. So there's a 2 here. This is 1, 3, 4, or 5. And, okay. 4 or 5 goes on here with this digit. Does that mean... If this is 2, 4, that means this is a 1, 3 pair, and there's a 5 on here. So this would be 8, 9. Can it be 1, 2, 3, 4, 6? With 5 on here, with 8? Yeah. Huh. What can I do about or say okay. I didn't glance at the second counter on my clock, but it looked about same-ish. Oh, good. So, what can... Ah, yeah, that'll do it. Sometimes, one thing that also helps is going in settings and toggling and untoggling low latency. I unset it and then set it again, and that skips ahead. Okay, so what can I work out which of these is... I guess this digit must go here in this box, because it must go here. And at least one of these must go out here. Wait, these can't both go out here. So one of these goes out here. And the other is one of these. Now, if this is 7, this is 8, 9. If this is 6... Oh. Okay, if these are... Right, if this is 8, then this is 7. Oh, then that's 9, 6. Then that's 7. Those are 9s. Then that's 7. So there's... In that world, there is... Four, 6 on here, 5, 8 on here. So this is 6, so this is 6. And then this is 6. Okay, so in that world, these are all 6s. Oh, so that's 6. So there's a 6 on here. There's a 6 down here. There's also 9s to think about. In this world... Wait. Oh, wait. If this is this is 9. Oh, that breaks up here. Yeah, that breaks up here, because I can't make these 7 and 9. That's it. Okay. So these are not 7. Or at least this is not 8. Okay, so this is... okay. Ooh, times 2, indeed. Alright. So there's... okay. How does... So it's 4, 6, or 5, 7. Now if there's an 8 on here, these are 9s. The 8 goes down here. There's also... no, can there be a 6 on here? If this is 3, this is 5, 6, this is 4, making this 8, 7, 9, 8. So these are 8s, these are 9s. Wait. Or 8. Oh, 7. 7. 8, 7, making this 9. And this 8, this being a 7, that doesn't resolve these. Okay, but... yeah, I did... yeah, let me go through it the proper way. If there is... if this is 3, this has to be a 6, 5 pair, with this being 4, this being 3, this being 6, oh, and this being 9. 8, and these being 9s. Okay. So this would be 1 through 7 in that case. I think, don't these always add to 11? Because it's 4, 7, or 5, 6. If it's 4, 7, then these are 5, 6. And if the... okay, but if these are 5, 6... Oh, this can't be 8. Right, so there's no 8 on here. So this is either 4, 5, 6, 7, or 3, 4, 5, 6. Okay. Now there's no cell other than this that all of these see, so that's not too... Well, maybe... What is... Okay. What is this? Oh. This is... If this is 3, this is 2 or 4. That would be... interesting. If this is 4, 7, this is 5, 6. There's also 5 and 6 on here. Where does this digit go in this box? Can't be any of those. Where... neither of these are 1 or 2. And this also isn't 3. Should I think about where the 5 can go on here? Oh, if there's a 3 on here, it has to go... No, there's no 3 on here. So I know there's a 5, 6, 7, and 8 on here. Okay, that's not 8 or 9. Yeah, if this is yellow, then it's 9. One and 2 in this column. So at least one of them goes down here. Oh yeah, this goes here or here. If it goes here, then it is not yellow. So this is 9. these is orange. Means orange goes in this box somewhere. This sees yellow and orange. I get that it sees orange. How does it see yellow? Oh yeah. So the spots for 8 on here. Yeah. I saw that earlier and then forgot about it. Also, oh yeah, this is not 8. If this is 8, then this is 8. Then all of these are 8. Well, this can't... It's across the Renbon, but this sees these, which are the same as these. So this does see all of these, just very indirectly. Alright, and... Could these both be 9? Could make these 9. 8. So this is 9 in that world. Just leaves that to finish the 9s, which I guess works. Then, what else can I... If I could prove that there is a 4 or that there isn't a 4... Oh, well this can't be 8 or 9. Because it sees yellow and orange. So, if this is an 8-9 pair, if this is 8, oh, if this is 8, it's yellow, which it is not. So this is 8. Now that doesn't actually tell me whether 8 is yellow or orange, but we are getting... If this is 9, then this is 9. Oh, then this is 9, so this is 9. But if yellow is 8, wait, if this is 9, wait, I had that backwards. If this is 9, then this is 9. Right. This, and then but then this is an 8-9 pair. Because if this is 8, then 8 never goes on this renbon, for what that's worth. And these 2 digits must go on this renbon. So I guess that's sort of a very weird mutant X-Wing. So I guess these 2 digits in this box only go here. So, pink in this box goes here. Pink does not go here. Oh, well, okay. 8 in this box only goes here. So it is no longer possible for these to both be 9. I know that these both go on this renbon. Pink goes in one of these. There's neither of these that they all see. Red can go in any of these. Is there a... Oh, where do they go in box 1? These go here in box 1. Not here. Okay, they go in these 3 cells in box 1. So if one of them goes here, it then goes here. Oh? Oh, yeah. So there's a 3 up here. If this is 8, all of these are 8. Oh. Right. Okay. If this is 8, 4, that's 9, 7, that's 8, that's 4. But if this is 2, 4, how does that resolve this? Oh, yeah. Okay. Okay. Wow. Okay. So no 9s on here. Oh. All right, this can't be 5, 6. In fact, this is 5, 6. This is 3. That's 2, 4. Oh, this is a 5, 6 pair. So that's 4. That is 7. So there's a 7 down here. Okay, so now that's 2, that's 4. Oh, that's 1, that's 2. This 4 looks up, making that a 4. So that's a 2. This is 1, 3, 5, 6. Oh, so that's the 2 in this column. Oh, this 2 looks over, makes that 1 and that 2. So this is 1. So this could still have an 8 on it. Oh, but this is an 8. There's an 8 here, and it doesn't go with a 9, so this is 7 or 8. This... Oh, and I know there's a 2 on this Renbon. Where does it go? It has to go there. Two in this box goes down here. So there's a 3 here. Ah, and it's not there. So that's 3. So that's 3. This is 2 or 4. It is not 2. It is 4. I think the coloring is mostly served its purpose, and and I don't want it to distract us from the prettiness of the grid itself. 3, 5, 6, 9. 4 in box 5, yes. And in box 8 as well. And in box 7, oh. That's all the 4s. Let me go digit by digit. See if I'm missing any Sudoku deductions. This gets me an X-Wing on 3s, which places this 3 up here. 5, 8, and 9. That's 5 or 8. One, 2, 7. Oh, 7. Oh, and that's 2. This goes here. These are here. This sees both. This also sees both. Okay, I believe that's all the threes. Aha! Okay. Oh. Okay. Row 7, column 1 must be 1. Because if this is 1, it's being 5, 6, 7, that's 1. That's 8 that breaks. Okay. So this is not 1. Oh, right. This can't be 7 or 8. And it doesn't go on this Renbon. Or 9. So, yeah, this is 2 through 8. That is an easier way to, So, okay. This is 5, 6, or 8. It's the same as this. Does it see green? Oh yeah, there's roping here. Five, 8 pair here makes this 6. So yellow is 5 and green is 6. So that's 9. These are from... This is 5 or 8. It is 5. Six, 8. 6, 7, 8 makes this a 1. So there is a 6, 7, 8. Okay, so that's 7 or 8. Now that's 1. That's 2. Oh wait, no, that is 5. That's 6. Oh, this is 6. Okay, that's 8. Oh. 6. Whoo! And give her the crab rev. That was amazing. The fact that all the clues are symmetrical, I can see why this took a while to set. Because that is, speaking from experience, it is very difficult to set a fully symmetrical puzzle this restrictive. Thanks for the GGs. All right, well, thank you so much. That was a really cool one to end on. Yeah. Yeah, that was absolutely gorgeous. Wow. Might add that to my favorites. I actually know might about it. All right. Okay. Doesn't look like anyone's on doing puzzles. But Vil is streaming voice. Remember the one I made for Soder's birthday. Alright. Oh, so you. Ooh, nice. Gorgeous. Alright, I will try that. I will add that to the queue for Thursday or whenever I get around to it. Alright. Alright, well, that was a lovely surprise. Yeah. I'll send you over to someone playing Voices of the Void, one of the indie breakouts from last year. And yeah, that is... I'll be back on Wednesday with more Artisan of Glimeth, and on Thursday with more puzzles. All right. Thanks for joining me, and bye.